From a biological standpoint, the cells meant to protect you from the sun are the most likely to be corrupted by it. Most of us treat our moles as harmless marks on a map, but inside those small dark spots, your DNA is fighting a constant war against a genetic glitch. Usually your body wins, but when it loses, a tiny spot in plain sight can turn into a silent traveller that threatens your entire system. So to fully understand the danger, we first have to look at what a mole actually is. Inside your skin, you have specialised cells called melanocytes. Their entire job is to produce melanin, the pigment that protects you from the sun. Usually these cells are spread out evenly, but every so often, they lose their sense of personal space. They start to huddle together, forming a concentrated cluster. That cluster is a mole. For the most part, these clusters are harmless. They're like a dormant city of pigment cells living in a quiet suburb of your arm or back. But here is where the curiosity turns into a concern. Because while most moles are content to just sit there, some of them are hiding a glitch in their programming. Inside the nucleus of those cells, the DNA is constantly being battered. Usually it's by UV radiation from the sun. Most of the time, the cell repairs the damage, but occasionally, the stop button in the cell's genetic code gets broken. When that happens, that quiet suburb of cells starts to expand. This is the science of why certain moles are so concerning. It's not the spot itself that's the problem, it's the instability. Scientists look for what they call the ABCDEs, but the physics behind it is what's fascinating. A healthy mole is symmetrical because the cells are growing at the same rate, but a dangerous mole, a melanoma, is asymmetrical because the cells have lost their biological rhythm. They are growing chaotically, pushing out in different directions, creating jagged borders and uneven colours. But the real reason these spots are so terrifying isn't what's happening on the surface, it's what's happening underneath. Your skin is a barrier, but it's also a gateway. Just a few millimetres below that mole is a massive highway system, your lymphatic vessels and your bloodstream. A normal mole stays in the top layer of the skin, the epidermis. It's walled off, but a cancerous mole learns how to dig. It starts to grow vertically, pushing down into the deeper layers of the dermis. The moment those rogue cells reach the highway, they can break off and travel. They can go anywhere, your lungs, your liver, your brain. This is why a spot smaller than a pencil eraser is so concerning. It's the only cancer that starts in plain sight, but can vanish into your system before you even feel a single symptom. It's an evolutionary paradox. The very cells designed to protect us from the sun are the ones most vulnerable to being corrupted by it. So the next time you're looking at a new spot, or one that seems to be moving or changing its shape, remember, your skin is trying to tell you a story. It might be a harmless glitch, a simple cluster of cells enjoying the sun, or it might be a system that has lost its way, trying to grow beyond its borders. If you're fascinated by how our bodies have biological glitches, you need to see what your cells do after experiencing Chernobyl-level radiation.